do make sure that you read the words here, don't just look at the diagram. You're told that you've got a triangle, that's very obvious. Midpoint of PQ is W, so this point is halfway along PQ. X is the point on QR such that QX to XR is 2 to 1, so the ratio of this bit to this bit is 2 to 1. You're told that PW is the same as A, so this is the vector A, this bit here is also the vector A, and from P to Q then, I like to put it out here, must be the vector 2A. And PR is the vector B. Right, that's everything on the diagram, all understood. First of all, I'm going to find QR. Okay, well, to go from Q to R, I can't go directly in terms of A and B, so I'm going to go first of all from Q to P, and then I'm going to go, which means add P to R. So go the long way round. Right, the vector QP, well, I can see that PQ is 2A, so QP is the reverse of that, which is minus 2A, and then PR is going to be B, and I usually write that the other way around, so I'm going to write QR is equal to B minus 2A. Okay, let's go on to the next one. Okay, we're told now to find the vector QX. Well, to find QX, I've just found what QR is. So QX, if I look at it as a fraction, QX is 2/3 of the way from Q to R. So QX is 2/3 QR. Now I can write it then as 2/3 times B minus 2A, and I usually remove the brackets. So QX is the same as 2/3 B minus, and if I do 2/3 times 2, that's minus 4/3 A. So that's the vector QX. I'm now asked to find WX. Okay, so here's W and here's X. Well, it makes sense if I'm going to find WX, I'm going to use QX. So for WX, I'm going to do WQ plus QX because I've just found QX. Right, WQ, if we just go down, well, WQ I can see is just A. So it's A plus, well, here's QX, so it's 2/3 B minus 4/3 A. And I put the A's together. Well, A minus 1/3 A, well, that's going to be, sorry, A minus 4/3 is minus 1/3 A, and then plus the 2/3 B. And I'm going to swap that round and write it as, well, let's write it as WX is equal to 2/3 B minus 1/3 A. Okay, so the next thing I'm told is that R is the midpoint of the straight line PRY. So this is the vector B, and because R is the midpoint of PY, then this bit here from R to Y must also be the vector B. And the question says use a vector method to show that WXY is a straight line. Well, let's have a look at the diagram. There's W, there's X, and there's Y. And let's look at what we've already found. Well, we already know the vector WX. So we already know this vector. So let's just write that one down. So I know what WX is. So WX, which we've just found, is 2/3 B minus 1/3 A. So that's the vector WX. Now I need to prove that WXY is a straight line. So I'm either going to find XY, so this one from here to here, or I could find WY. It doesn't really matter which one I find. I think I'm going to find WY because it looks a little bit easier. Yeah, that's probably easier. Okay, so to find WY, I'm going to go from WP and then P to Y. So let's just write that down. So WY is the same as WP plus PY. Okay, so the vector WP, well, I can see that WP is just minus A, so it's minus A, and then PY, that's easy, well, that's just 2B, isn't it? So it's minus A plus 2B. Okay, if we just extend it. So looking at this, if I factorize WX, well, I can see that I can take out a third. So WX is the same as 1/3 times 2B minus A. And if I look at my WY here, well, WY is just 2B minus A, which means that in fact here's WX. WX is actually just 1/3 of WY, or the other way round, I could write it as WY is equal to 3 lots of wx. Now if we look at that on the diagram, well, we don't even need to look at it on the diagram. It tells me that wy is parallel, so wy is parallel to wx. Okay, so wy is parallel to wx, and also we are talking about two vectors which are parallel but both pass through point, so both pass through w, so both of them pass through w, therefore wxy must be a straight line. Okay, so we've proved that we've got two lines which not only are parallel but they pass through the same point, which is w, so wxy must be a straight